So towards cloud native and AI-driven transformation of modern telecom communication infrastructures. I go through where we are and where I think we need to still work in order to achieve our division presented on this title. About me, I think you know me already, active on the ST field, I think for over 25 years now. I played both as an academic, as an industry player. Industry, I spent most of the time with Nokia, Huawei, and now it's around approaching 5 years. Later in August, I'm with Rakuten, so I served Rakuten across 2 roles. The first, I operated as Chief Information Security Officer for Symphony, and then I was handed over to Rakuten Mobile, and I'm running the next generation advanced research division or department. Well, maybe one more thing is that in the last 5 more years, I have shifted my focus from wireless network to cloud native computing technology. So that's the core, and that's where my team members are all focusing. So let's go through now the cloud native aspects of our infrastructure. So what are the main blockers? What are the main problems? If we look at the reports and analysis we find on the internet, we will see that we are not there yet. And the main reason are basically the one listed on this slide. I'm particularly mindful of the architecture complexity, legacy system integration, workflows readiness, deployment AI capabilities, and of course, the computational efficiency. So it's a very hard step for the people coming and having only telco background and developing and deploying and using monolithical type of infrastructures. If you look at the AI, without the AI challenges, so what prevents us to make our infrastructure AI native, or our applications in AI native with ability to run on AI platforms? I have identified a couple of main blockers in terms of costs and utilization. So if you look at okay, we had a presentation from Intel, very interesting. And I tend to agree with them because we are still, most of the applications we are having, even on our infrastructure running, thinking of AI workloads, running on CPUs. And we do not have clear use cases where the GPUs are really used. But if you want to go into the directions of making your system run AI workloads, thinking of very large language models or complex AI agentic workflows, you need to use GPUs. And we have started revisiting the entire infrastructure, entire stack. And the main bottlenecks are basically the following. That first of all, your system is in idle most of the time. So the GPUs or CPUs you're having are not used. So you go to your data center, you end up, oh, look, even during the high peak load, I am only using, say, 40% of my compute capacity. Then, when you jump into the details, say, okay, now I want to modernize my infrastructure and perhaps add a few GPUs in my racks and targeting, for instance, like Deutsche Telekom have done. And I think all operators should move into that direction. And AI farm, you will end up having a demand of around 100 megawatts data centers. So that is more than 10 times what is currently needed to run our current workloads. And then when you look at the costs and you go to the shopping list, these are rather dated, but recently we end up into having around 25 to 30K per GPU. So you can see here that the costs per token, per dollar per watts are really, really, really extremely high. So what we need to do here is to look into the stack of AI and look at the way we utilize and mount the hardware underneath so that we can optimize the token per dollar per watt and bring at 100%, 90% utilization of our hardware, particularly thinking of GPUs. How we get there, I will show you in a moment. Where we attract the mobile, I think we are the most advanced network in the world in terms of virtualization and networking, so cloud native networking. Around 5 years took us to achieve an entire deployment in Japan. We have more than 350K cells on 3 single CDC, so the central data center. We have more than 40 RDCs and more than 2,400 edge data centers. So you may kind of calculate how many clusters we are having here. If you think of embedding them with the GPUs, you can see really that the prices and the energy consumption will be prohibitive, right? Overall, through this architecture, we managed to save 40% of CapEx and 30% and more of OpEx reduction, now even more, because we have a massive introduction of AI. So where are we today? So all this complexity, I tried to bring that on a single slide, and it is here represented. So today, our reference architecture looks as the one depicted on this slide. We have multiple layers. If you think on containerization, your data center run on Kubernetes, and then on Kubernetes, we are bringing our virtual network function, which were not designed to be containerized. So that you have a massive effort to move from your VM type of approach to a infrastructure that does scale efficiently and effectively on Kubernetes and the different variants and plugins, but it's still on a container orchestration platform. And there are many projects aiming at alleviating this effort, introducing large degree of automations. You may think of Nephew, introduces automation across these 3 main functions. Then comes along Porch and Silva now that look also automating the GitHubs. And then Silva expands even the footprint, achieving the Telecom grade GitOps-based lifecycle management. Are we there? I would say no. They're all workarounds. But what we will need to do now, next, thinking of 6G, is to shift towards a completely cloud and AI native infrastructure, which will mean that your workloads would be designed from day one. So that it's like you have a fish. You don't know where to put the fish. You go down a pond of sweet water, or should go into the ocean with the salty water. So that's your workload. You should go to the ocean and stop going on VMs. Going to the ocean means you need to be a fish that lives in salty water. So you will need to redesign the functions on the network as a cloud native, so they can run on any type of Kubernetes compatible platform and decouple from the workload. So the workload should be running there full stop, just a command, not having any sort of customization or forcing operators to buy specific vendors' platform. At the same time, it has to be AI native, which means that the workload needs to be compatible with my AI platform, so that I can exchange services between my AI workloads and the applications that are specifically network function and other application, all running on the same exactly decoupled cloud native platform. You do see another important component, which I'm touching upon. I don't know why it's keep moving. It is eBPF. eBPF is where most of my team members are currently focusing. What is it? It is a virtual machine of the Linux kernel. So wherever you're running the kernel, Linux kernel, and you will run that across all devices. If the kernel version is recent enough, meaning that younger than 2014, the year that it was born, we have ability to run these eBPF programs in real time and instrument the Linux kernel as we please, to achieve what? To achieve advanced networking, observability, security tuning. Now, where are we in terms of ecosystem? I analyzed the ecosystem portfolio, how to become cloud native, and there are many, a variety of projects. The problem we are having, yes, they are all, many of them, they are successful. If you think of Orange, Vodafone, basically they do very well. So this is the Vodafone, the Orange ecosystem, and what Vodafone wants to achieve is exactly what we have achieved. That means they are thinking of having a 6G network where to deploy a VNF would just simply through a kubectl command. If you need to have then, for example, a patch to deploy a particular change request is yet another command. So I don't need to code that vendor, oh, give me that a box, expand the cards. Absolutely not, just simple VNF command. Are we there yet? Not yet. Why? Because there is discontinuity between this kind of initiatives and the main driver of the design of communication systems, thinking of 3GPP, ETSI, and other SDOs. Where are we with AI? So AI is currently shifting from, say, data-centric to model-centric. And when you go through the stack to run AI on your infrastructure has completely changing, and it evolves as we speak. Why? Because we need to bring AI workloads on Kubernetes. So we need to make AI scalable. In order to achieve that, you need to have, in addition to a proper utilization of the hardware, otherwise explosive in terms of cost and energy consumption, you need a nuclear power plant attached to yours. So you need to redesign the complete stack, hardware and software. Here you have an example of a software stack. I'm not going through it, but I tell you that you need the entire stack to have an efficient way of computing your AI workloads along with your cloud native function and other services. And then we're shifting from LLM models to agentic AI workflows, a lot used because AI per se and the language model per se waste your time. I posted on LinkedIn that AI wastes your time and makes mistakes, an LLM. But if you are evolving this through multiple agentic workflows with very small model, then it executes properly according to your needs. And there are various technology coming, like the agent-to-agent protocol of the model context protocol. There are upper layers, so I call them a sort of service mesh, a protocol that makes it possible to create these agents and then make these agents into communication so that you can shift from something that wastes your time, that's a language model, because it produces inaccurate. And I will give you an example at the end of this meeting. Inaccurate information that you need to go through again. Oh, but it's true, false, true, false. There are many mistakes, and even one mistake that they may collapse your solution, or they may collapse your, say, business plan. So we need to have to shift from a language model to an agentic AI workflow that execute for you with limited ability to make mistakes. So we focus on eBPF. If you look at eBPF, so this capability of the Linux kernel, which I think is the most powerful and revolutionary technologies I've seen across my career. So I've been in this industry for over 25 years, Huawei, Nokia R&D centers. This is really revolutionary. Now, the applications are mainly three, but there are also other use cases. If you think of handling language model, particularly thinking of the controlling what a language model is doing, or even agentic AI workflow is doing. But currently, specifically, we have three main use cases. We have observability, we have networking, and we have security. And if you look at the investments, they've been really massive since 2020. And more than 50 companies today, they incorporate eBPF in their solutions. And recently we have the acquisition of Google VITS. VITS is around security, runtime security of 32 billions. What we are doing, and here I am concluding my presentation, in my organization, we have created an eBPF platform denoted as Sauron. It is a Rakuten Mobile in-house solution. And we have currently developed 4 models. Or the first one is about on transport. So we generate synthetic packets. And we may run our agent on any device. It could be like a router, it could be like a server, it could be a switch, anything. We are now even on internet services that one generates synthetic path, the other reflects, and we have ability to measure the link level performance in terms of JIT quality of service, packet losses, and latency. Observability, ability to extract any packet across any virtual interface, and then security, which means for us, we have ability to detect any sort of event. Above this, we are now building our AI models, and then we will also make use of language models so that we can achieve an agentic AI workflow to do what? To do what? To handle, on the one hand, the data we receive through eBPF as an input source. And what eBPF provides us are unique data that there is no other methodology, network interface, probe, or whatever you can use to extract them, because we have ability to tap across the entire stack on your node, in the server. On the other hand, through description, I would say use cases, intent, you name it, we can then translate this into executable policy. And the enforcement is again done across the Linux kernel or the application, as each node has a single kernel. Okay, we have currently achieved, and we are in production with a transport model here. We have ability to extract any sort of information. Our performance are above the gigabit per second. Using TCP or UDP, it doesn't matter. We have ability to mirror the packets, analyze them. In security, we can capture any sort of event. You may think of any kind of system calls, network activity, or security signature. So that means something happened in real time without passing this information to the user space, so we can execute and kill that particular process. Or we can even monitor the energy, because we have a telemetry that through eBPF, we can estimate how much energy each of the workload consume. Next, now, we introduce this concept into the GSMA white paper Venus. Next is to work together with the Uran Alliance work groups, 3GPP, and other technical specification organizations, so that eBPF could be an integral part of the network design. That means the control plane of the next generation networks to achieve advanced networking, observability, and security tuning. Okay, I finished. Now, where I see the business and the needs going, if we really want to make our system truly cloud native and AI native and working without, say, additional effort to customize the workloads because they're not running on our platform, whether it is in a cloud platform or it is an AI platform. Okay, first, you can see that AI comes at a massive hardware and energy costs. We can debate whether we need GPUs or not. We will need GPUs. We will need anyway an extremely high capability to compute. My suggestion is to enhance the GPUs with a GPU through hybrid models for handling CNF and AI workloads at the same time, because you don't want to have a different infrastructure. You want to have an infrastructure that runs everything. So in my cluster, I don't want to have a specific cluster for AI workloads. I want a cluster that runs any workload efficiently and effectively. In order to do that, now what we need will be to properly scale the workloads in the cluster, and there are various techniques to do that. Diagonal autoscale is where we are currently focusing, or we need to have new technologies like composable disaggregated infrastructure, where I could share the pool of GPUs in the cluster. So among nodes, currently you mount them vertically on your node or between cluster, and then schedule accordingly all the workloads across the entire network. Like we have more than 1,000 clusters, I should be able to schedule my workloads wherever I need. And then have also ability to dynamically allocate the resources of different GPUs. That's the first thing. The second remark, if you go into the detail and you use AI, the one that is provided to you through the, for example, language models and through internet. Today, you can find that it is questionable its reliability, and particularly if you think of having as an autonomous source of truth or innovation, it doesn't absolutely innovate nothing. It is even proved that the language model that apparently resolved some mathematical problem, AI found references that somebody else couldn't, and then it's all basically coming because it's a review work. It does not innovate anything. So what we need to improve, what we would need to improve to achieve a better reliability and reliable data. We need to improve the selective recall, so the memory, the way that this massive amount of information is retrieved and used. We need to improve the method through reasoning, that we can have a better reasoning and planning, which currently is not doing it, particularly language models. The word models also, now if you think of the rendering and use like capabilities to detect the environment around you and elaborate that, we still need to improve the predictive consequences of the actions, which it's not working, it's not there. We need a better and efficient reasoning, and then we need to find a way to integrate AI with the humans. Currently, we say humans in the loop, and here I tend to agree with the Jensen Wang that says that AI has to be in the loop. I agree with that, but what is the best way of doing that? So we need to design that better. eBPF, I think, should become the de facto standard for runtime security. Crypto monitoring, for example, we can detect whether a system it is post-quantum cryptography compatible or not. And then link that to the agentic AI workflow so that we can achieve real-time observability control of the system across any device, from the mobile to the transport network layer and the AI workloads. Also, if you look at all the work done till today and maybe even tomorrow, I think most of the research has been done on the 6G. The concept you find across various fora, if you really look into that seriously and that you understand the stack, not the PowerPoint, the slides, architecture, you go through really the stack, there is nothing new, okay? What could enable, I think, the innovation, generate new services, if it really this network function would become cloud native and would integrate on a cloud AI native architecture and technology innovations deeply. So we need to really redesign these functions. Rather than architecture level, we need to think deeply at the implementation level, because finally, this not PowerPoint need to run, and where to run, they have to run on a Kubernetes, not running on monolithic hardware. In the past, we used to design architecture level, MATLAB simulator, and then you were thinking that it was even offensive to the intelligence to think how that was implemented. Today is absolutely the other way around. You need to design something that is completely agnostic from where it runs, So therefore, you need to understand that fish needs salty water and not sweetie water. So you need to rethink about this. It's very, very, very important. How to achieve this? I think we are not there yet. We will need probably you need to get rid of all the Telecom people, I think. So we will need another 10 to 20 years to achieve a system that is truly cloud AI native. And in order to do this, the first step is to integrate effort coming from the Linux Foundation, where you have an open source type of ecosystem with the Telecom. And currently, all the discussion I'm seeing, the two organizations are water and oil, because there is not the same understanding of the entire stack. Okay, that's pretty much what I want to share with you. We made some white paper where you may find more details around eBPF, our ability to analyze anomalies using this technology. Thank you.
Oh,